Let us see a simple application here. So here I have taken an example of what to say. It's a pattern recognition problem where I have taken an image. Okay, so image in the sense, don't think that the JPEG image will be taken as it is. Okay, so the information, the measurements from that image will be given as an input to this what is it, the network. So here I've taken the breast cancer, sorry, cell images. So I'm going to classify whether that the cell has is a cancerous cell or it's a non-cancerous cell. Okay, so I'm giving here, I'm loading that data set. So this data set is already available. So load that cancer data set. Don't think that it's in the form of image, JPEG. It is actually in the form of Excel. Okay, so load that. And then I'm giving here the inputs is equal to cancer input and the target is cancer targets. Okay, so this is number of hidden layers I'm fixing here as 10. Okay, and here I'm using pattern recognition. So I'm using that the pattern net. Okay, so net is equal to pattern net of hidden layer size. And here I'm fixing that number of samples. Okay, so out of 100 samples, 70 is taken for training, and then 15 for validation and 15 for testing. Okay, now I'm going to train the network. So if you train, you have to use a keyword train, net, inputs and targets. So inputs is nothing but here in this, you have here in this cancer data set, you have cancer inputs and cancer targets, which means that based on the cancer inputs, already it's a supervised learning. So cancer targets are being fixed. Okay, so if your image is going to have some if you have some abnormality, automatically the values won't be proper. In such cases, the target will say that it is 1. If it is 1, then it says that it's a cancerous cell. If it is 0, it says that it is a non-cancerous cell. So those cancer targets from this data set are being loaded into a variable target, and the cancer inputs are being loaded into inputs. Okay, now I'm going to train the network. I'm fixing the number of layers here, and it's a pattern recognition network. It's a feed-forward network. Okay, and tan sigmoid transfer functions by default will be taken both in the hidden layers and in the output layers. I'm fixing the number of hidden layers here as 10, which means that I'm going to have 10 layers. Okay, and here let us view the network now. You can use a keyword view to view the customized network. So now let me run this. Sorry, hidden layer size. So this hidden layer size in the sense that number of neurons in that layer. So input, and this is pattern network. It's a feed forward network with one in hidden layer, one output layer, and this is a input, one input and one output here. And this number of neurons in this layer is 10 because it's a hidden layer size, not hidden layer. Hidden layer size is nothing but the number of neurons in that hidden layer is 10. Okay, and it is a log sigmoidal function. As I told you, the pattern recognition network by default will take tan sigmoid function as the activation function here. Okay, in both in your input and the output layer. Okay, so this is actually the network. Now let us go for fixing the number of samples for the training and the number of samples for the validation and the number of samples for the for testing. Okay, now we'll go for training the network. So for the training the pattern recognition network, you have to use your train, the keyword, and net is what is that network we have customized, and inputs is the cancer inputs and the targets is a cancer target. Just we are training it. Okay, so accordingly by taking the inputs, the network gets trained. Okay, so this is for training your network, and then you'll go for testing the